Hello, Mrs. B here, and we will be continuing with Lesson 5, Investigating Soil Permeability. Now, this is part 2, so if you haven't seen part 1, I suggest you go back and have a look at that video. Okay, so what does permeability of soil mean? Permeable means that liquids can flow through it, and there it is, going right through, coming out the other end. Semi-permeable means that some liquid manages to flow through it. Not a lot, but some liquid is still coming through. Impermeable means that liquid cannot flow through it, so it doesn't go through it. Why does it matter? We grow much of our food in soil, including vegetables, fruit, wheat, and rice. The permeability of soil affects which plants will grow and how well they grow in certain soils. Testing different types of soil permeability experiment.
You watered your plants, but where did all that water go? Let's find out by looking below the ground into the soil. Soil is made up of particles of broken down rocks. These particles have open spaces between them, which are called voids. When water is added to soil, these voids create a pathway through which the water flows. This tendency of water to flow through soil is called permeability. Soil particles can be of different sizes. Some are large, while others are small. Large particles have larger void spaces through which water can flow easily. They have high permeability. On the other hand, smaller soil particles have smaller void spaces, and thus lower permeability. This can be easily explained using a simple experiment. 3 types of soil samples are taken: gravel, sand, and clay. They are placed in funnels, and 100 milliliters of water is poured into each one. We can see that water flows quickly through gravel. This is because gravel has large soil particles and hence higher permeability. When water is added to the sand, it takes more time to flow compared to gravel. This is because sand has smaller sized particles than gravel. On the other hand, clay has the smallest soil particles among these samples, and thus the lowest permeability. Even after an hour of testing, water has hardly flowed through the clay.
Okay, let's have a look at the results of that experiment. So with the gravel, there was what we call rapid drainage. The water came through quite quickly and a lot. With the fine sand, there was some drainage, meaning the water came through, but not as quickly as the gravel and not as much. With the clay, there wasn't that much, and it took a long time for even a little bit of water to come through. If you were doing it with solid rock like a brick or granite, you would actually have no drainage or no water coming through whatsoever. So I want you to try this experiment if you can. So you can place a funnel in a glass or plastic cup. You can also make a funnel out of paper, and that's in the next slide I'll show you. Add the soil sample to the funnel. Pour some water into the soil. Observe the water filtering or coming through. After 5 minutes, check how much water has collected in the cup or glass. Repeat this for different soil samples if you can get them. And I've just put a little picture of here how you can make a funnel. You can stop this and have a look. So what I want you to do is task 1. Write up in a report the results of the experiment in the video. Write under each subheading, clay, sand, gravel, which is small stones. Explain which type of soil is permeable, semi-permeable, and impermeable. Explain the findings. Use the following words: soil, particles, broken down rocks, open spaces between, voids, large, small, pathways, water, flow easily. Have fun, and I can't wait to see your report.